Hello everyone, my name is Nicoya, and this is the Casio CZ-101. Now, if you clicked on this video, you probably know what these keyboards are notorious for, along with the CZ-1000, which shares the exact same electronics, and that is a god-awful amount of noise on the headphone port. Well, I am here to say that I have solved it once and for all, and if you watch this video, you will be able to solve it as well. So go ahead and skip on the chapter markers if you want to jump straight to the fix, but if you want to find out what's actually gone wrong inside here and what the fix does, then stay tuned. So this is a schematic for the output section of the keyboard. We have the headphone port here and the line out as well. And you'll probably know that the line out port is super clean, super quiet, nothing wrong there. But the headphone port is just full of all kinds of static and garbage. And so that tells us two things. Number one, tells us that as far as we get to here, this is where the signal comes in, it is pristine and clean, so it's no problem there. And so number two, that means that the problem has got to be somewhere in here. And so the problem is actually the gain staging. So if we look at the line out, we have a 6 op amp here with a 62K feedback resistor and an 8.2K input resistor. So if we look at our dB calculations here, remember that for our voltage gain, we have a 20 log 10 of R1 over R2. And for 62K of R1 and 8.2K of R2, we have about 17.57 dB. And so we're getting about 17.5 dB of gain on this path, and that goes to the line out. But this is just a regular op amp, and it doesn't deliver a lot of power. So you can't put this into a low resistance, low impedance load and expect to not distort on that or, cook the op amp or whatever. So that's why it's a line out. It's designed to go into some other amplifying circuit. Now, if we follow the upper path here to our headphone port, we see that we go through the other half of this op amp. It's just a dual op amp with 10K and 12K. And so in that case, we have 12K and 10K. We only have about 1.58 dB of gain here. And so where's the rest of the gain coming from? Because this is a pretty low signal at this point. Well, it comes from this audio amplifier here. And so out of the box, it has something like 51 dB of gain. But with this resistor here, which is 680 ohms in the original circuit, they actually knock that down to approximately 29.37 dB. So in this case, R1 is internal, it's fixed at 20K. The external R2 is 680. And so we use this formula, we get about 29.37 dB of gain. And so what we want to do is we want to change this gain staging because we are getting too much gain here in a place that is sensitive to noise. And in fact, if you reach in and you touch the top of that capacitor, you will blow your eardrums out from the amount of static and noise that is just coupled from your hand into the circuit. And so this is where a noise is definitely coming from, and we want to reduce that by increasing the amount of signal that's going through here, which means increasing the gain here, and then lowering the gain here so that we don't completely overdrive this chip and end up clipping and doing whatever. And so the first thing we're going to do is we're going to replace this resistor here, this 12K resistor, and we're going to replace it with a 68K resistor, and that'll give us about 16.5 dB of gain, about 16.65. And while we're doing that, we also have a bypass capacitor, that's hard to say, on this one of 470 picofarads. And to get the same frequency of roll-off somewhere above 20K, we want to switch that out, I should say, for a 68 picofarad bypass. And so that'll give us the same frequency response. We won't be losing all our high end. Now, to turn down the gain on our output amplifier, we're going to change this 680 ohm resistor for a 6.2K ohm resistor, and that'll give us about 10.17 dB of gain in that stage. And so any of the noise that's going to be picked up around here, instead of getting amplified by 30 dB, is now only getting amplified by 10 dB, and that's going to bring it way, way down. Now, these before and afters don't quite add up the same. Before we have about 31 dB of total gain through both stages. We now have about 27, and so we're losing about 4 dB of gain. I find this fine. if I turn the volume up on the headphones to max, it really blasts my ears. At least it does with these headphones. And so if you have these same headphones, you will probably not need as much volume. So I'm fine with dropping this down a little. If you want to play around with this gain staging, maybe bring up the first stage a little bit more. I mean, obviously you can get at least another decibel out of it before you exceed what's going on in the line out port. Or if you want to not bring down the second stage quite as far, although again, this is where you're getting your noise, and so you want to keep this relatively low. That's up to you. You can experiment pretty easily. Just, get yourself a jumbo pack of resistors, play around with it. But I chose these values, and they work out quite well for me. And so why don't we flip this keyboard over? We'll look at the PCB, and I'll show you where to locate these components. All right, so we have the back of the keyboard facing here, so the keys side is up there. I've just flipped the audio board over after taking out the screws. And we can see our LA4138 here, as well as our op amp here. That is 4558 DD, I think. Don't know. Yeah, 4558 DD. So whatever op amp that is, I actually have no idea what op amp that is, but it doesn't really matter. We're only changing its gain. And so what we want to do is we want to, oh, actually I should mention one other thing I did here is I actually added this capacitor right here. This capacitor, it basically goes between pin 14, which is the VCC, and a nearby ground. And there are actually holes to put exactly this size of capacitor in here. It is specified in this chip's data sheet, and adding that capacitor did nothing. So you can add it or leave it out. I don't really care. Anyways, back on track. The components we want to change. So this will be, I've already changed this, but this will be the 680 ohm resistor that sets the gain for the 4138. Over here, this blue one will be the 12K that sets the feedback for this op amp. And then this capacitor here is originally a 470 picofarad, and I switched that out for a 68. And so I have the new resistors in here already, but you just unsolder the old ones, solder in the new ones, and you're good to go. I'll flip this over and show you which pins to desolder on the back side. Okay, so here on the back side, we're looking at the capacitor, bypass capacitor for the op amp right here. Just below it is a feedback resistor. So that's what you're going to do to change the gain on the first stage. And then over here we have our second stage. This is a jumper here, closest to it, but the next pair of pads over is the feedback resistor for this one, and that's the one you're going to change out for the what did I say? The 6.2K. So you unsolder the old ones, you solder in the new ones, you clip the leads, and you're basically done. I'm going to put this back together. Oh, by the way, also the other mod I did in here, which I highly recommend, is putting a connector on the leads that go to the battery case on the back of the case, because they're usually just soldered directly here, and the two halves of the case are stuck together, and that sucks. And if you add yourself a little connector here, it makes your life a lot easier. So I'm going to put this all back together, including the power switch, in case you were wondering why it was flopping around before. And I'll give you a demo and show you that it now produces basically no audible sound out of the headphone port. I mean, no audible noise, I should say. It still produces regular sound. All right, got all the screws back into it, and it is powered on here. We are plugged into the headphone port, and that speaker is on maximum, and I'm going to grab my microphone and stick it right up next to there. And I'm pretty sure that you can't hear jack squat. So you can see that we still have plenty of volume. Sorry for the headphone users out there, it just blasts your ears out. But everything works. We have no issues with roll off or anything. Everything's great. There is like right here in the room, I can hear just like a tiniest bit of hiss, but honestly, my entire setup here is pretty noisy, so that kind of doesn't surprise me. but it is way, way better than it was. So if you have a CZ-101 or a CZ-1000, I highly recommend doing this mod. So hope you enjoyed this video, and I will see you on the next one.